Hi class, this is a video on Learning Outcome 5, Learning Step 7, Hypothesis Test by Analysis of Variance. And so as you read in that section, we have a few things to do here, and it's sort of out of the ordinary. What we're doing is we're using an F test. So we're using, let me just find that table. There's my F distribution. We're using the F distribution. Now the thing about this is that you'll notice there's only degrees of freedom on both sides, and that's because we're actually always assuming in this class that alpha is equal to 0.05. I know we're doing it implicitly with the other stuff as well, but you rarely ever, well, at least in the classes we teach, you rarely ever deviate from that alpha equals 0.05. So whatever the case is, we have to kind of move through making this table. So I'm going to build this table myself over here, and we're going to walk through how to fill it in. So we have source. Okay. We have df, the degrees of freedom. So this tells you the degrees of freedom that you're using. This is helpful when you're looking up the, I guess we have the formula here. This is helpful when you're looking it up on the table. So it's nice to set this stuff up this way. It makes life pretty easy for us. We have ms. And then finally, we have our F value. So we're going to, you'll notice that, you see, you get MS between, MS within. So if this is all of our, so this is between, this is within. And if you want an explanation of this stuff, I'll encourage you to read, if you're in Stat 202, read the chapter. I'm sure if you're in another class, there's textbooks or course manuals that will help you figure out what these all mean. I'm just trying to walk through how to do this today. So yeah, basically we're just going to go through this table and then put it all together in the end, and I'm going to be filling it in as we go. So let's take a look and figure out how we have to figure this out. So what we're going to be doing is we first of all have to add in, well, what do we need? We need n, and we need each of the ni's for the different number of categories. So there's 1, 2, 3 different categories. So there should be n1, n2, n3. Whoops, and there's 3 should be over here. And in the end, n itself is equal to n1 plus n2 plus n3. So the this equals the sum of all the samples over the different categories. And again, what we're testing here for is if there's a difference in the average number of overtime hours worked by nurses at these 3 hospitals. So it tends to be that with analysis of variance, and as you'll see in the next video, with the chi-square test, the hypothesis test, like the steps 1 and 2 are pretty much decided for you based on the nature of the problem that you're going to see. It's just the tricky part is figuring out these test statistics. So that's why I'm writing this column out first, because it tends to be the harder part of figuring this out. But so I'm just trying to lay out all the information that I need. So you'll notice that it has k. Now k is equal to your number of categories. And I know I didn't really read the problem. This is the number of overtime hours for nurses at hospitals in Regina, Saskatoon, and Prince Albert for the last month. And so the different categories, there's 3, because there's Regina, Saskatoon, and Prince Albert. That's 3 categories of nurses, essentially. I mean, you know, for the purpose of this problem, that's how we're breaking them down. So n is equal to the sum of each of these. Well, n1 is 1, 2, 3, 4, 5, 6, 7, 8, 9. Saskatoon is 1 less than that, so that's 8. And Prince Albert's 1 less than Saskatoon, so that's 7 that were sampled. So this is 9 plus 8 plus 7. So this is, I think it's 24, because that's 17 and 7, that's 24. Okay, so now we know what k minus 1 is. K minus 1 is going to have to be 2. And we know what n minus k is. N minus k is 24 minus 3, which is going to give me, wow, I can't do math today, 21. Now the tough part, MS is pretty easy once you know what SS is. But it's just this SS term that makes things kind of complicated. So let's figure that out. Now, TI is the sum of the I category. Okay, and there's actually a pretty easy way to do this on your calculator to figure that out. So T1 is the sum of Regina. T2 is the sum of Saskatoon. And T3 is the sum of Prince Albert. And then actually what T is, like that, because you'll notice that in here, we sum it all up and then we subtract off T squared minus N. T itself is equal to, you know what, I recommend doing this table beforehand. When you see this problem on a test, you're not going to be thinking, do the hypothesis test. You can kind of do the hypothesis test after and put in your test, or in your test statistic. So T is T1 plus T2 plus T3. Okay, and we'll figure that out. So let me show you on the calculator how I do this. So you remember on the calculator we're able to take a column, figure out the standard deviation, figure out the mean. Well, there's also a way to take the column and figure out just the sum. So let's enter the values: 34, 37, I'm just doing this for Regina, 23, 38, 29, 31, 25, 36, 34. It's 9. Now the way you do that is, where is it here? You see this little sum button? It says sum right there. Or no, sorry, that's not the right one. It's that one. You see sum of x? See that little sigma there? That sigma, that's the sum. So it's that little guy. So second function, this button, 287. 287. It can be helpful when you're figuring things out to find, it can be helpful to figure out TI squared, but let's just go with this for now. We'll do Saskatoon, 35. Then another 35, and then a 30, 39, 27, 33, 33, 31. Then we just do that same thing, the sum. You see that funky little thing up there, little green thing? That's the sum. So 263. Then Prince Albert. Prince Albert, we have 30, 31, 35, 26, 28, 24, 26. And then we just, again, take the sum. It's 200. Okay, there's a lot of computations, so sometimes, a number might go off or you might make a little mistake. Just keep following through the process. The important part is that you get through the process, and you get most of the marks if you're doing it mostly right. Okay, so 200, perfect. All right, so let's keep working through this. So SS, so let's figure out this SS term. So we have the sum over all the i's of TI, so this is SSB, I guess we'll say, for between. You'll notice here, see the sum of TI for NI minus that number. So TI squared over NI minus T squared over N. So in our context, what this is saying is, it's saying write each of these terms out and sum them together. So we have T1, T2, and T3, so we're going to do that. So we have 287 squared over NI, which is 9, plus 263 squared over 8, plus 200 squared over 7, minus, now remember T is the sum of each of these. So this is 287 plus 263 plus 200. So let's figure that out. That's 287 plus 263 plus 200. This gives me 750. So this is 750 squared divided by, and then the sum of n. So n is just all of these together. It's 24. So let's write each of these numbers out. We have 287 squared divided by 9, which I get 9152.11, plus 263 squared divided by 8, which is 8646.125, plus, you know what, let's put another 1 in there just to be consistent. 200 squared divided by 7. And I'm not adding that 1 in randomly. If you notice, it was actually 1, 1, 1, 1, 1, 1, 1, 1, 1 on to infinity. So it makes sense to add just one extra 1. It's 5714.286 if I round properly. Minus 750 squared divided by 24. It's going to give me 23437.5. So, it's a little complicated, hey? I'm going to start flipping back and forth here in a second because I'm going to have to move on to the next page after this. But let's put it all in. 9152.111 plus 8646.125 plus 5714.286 equals. Then I'm going to subtract off from that 23437.5. This gives me 75.022. Okay, 75.022 in the SS between. Now we got to figure out SS within. Oh, you know, there's another number we should have figured out when I put all those in. You know what? I should have. I'm going to have to go back and redo some of the work. What I should have done is I should have figured out SI while I was there, because you notice there's an SI term right there. So what I should have done was I should have figured out the sample standard deviation once I entered this all in. So I'm just going to enter this all back in quickly. So remember, sample standard deviation. So this is S1 is equal to 5.302. I'm going to use 2 decimal places just to try to have a little bit more precision. Enter it back in 35, 35. Again, the error that I made was I should have put these standard deviations in when I figured out the sum. While I had it in the memory of the calculator, it would have saved me a little bit of time. I'm having to go back and do it now because I remembered that there was this S1 or this S term here. Okay, so 30, 39, 27. So this is S2 equals 3.643. And then the last one over here, 30, 31. This is S3 equals 3.735. Okay. Okay, so let's we're gonna have to do some flipping, but we'll make it work. Okay, so S1. I'm just gonna write the standard deviations out here. So N1, because notice what I need here now to figure this out is I need the N's, each of the N1, N2, N3s, and each of the S1, S2, S3s. So I'm gonna write those all out. So N1 is equal to 9. S1 is equal to 5.302. N2 is equal to 8, and S2 is equal to 3.643. Okay, and then we have N3 is 7, S3, so N3 equals 7, S3 is equal to 3.736. Sorry, 736. Or no, 735. Sorry. 3.735. Perfect. Okay, I'm going to flip this over. And remember what we're going to be using now. So we're going to be using this formula right here. So we have the sum. So SS within is equal to the sum of Ni minus 1 Si squared. Put an I there. So this is equal to N1 minus 1, this is 8 times 5.302 squared plus 7, because again, I'm doing n minus 1, so n2 minus 1, 7 times s2 squared, so this is 3.643 squared, plus n3 minus 1 times s1. So this is 6 times 3.735, all squared. So let's figure each of these terms out. We have 5.302 squared times 8. So we have 224.89 plus 3.643 squared times 7 equals 92.90 plus 3.735 squared times 6, 83.70. So this gives me 401.49. Let's say 491. A little bit more precision. 401.491. So we put that over here. 401.491. Now what we do is this MS term. So this is SS between, so the one I just computed here, divided by DF, which is 2. So this is 75.022 divided by 2, right? Because I want this divided by this. So we go 75.022, and I divide that by 2. And I get 37.511. And then we have 401.491. So this is 401.491 divided by 21. This is equal to 19.1. Well, we'll say 1, 2. So now we have MS between, which is 37.511 divided by 19.12. 37.511 divided by 19.12. This is going to give me 1.962. Okay, so now what do we do with that? Why did we just compute that long process? Well, so that we can do the hypothesis test. I just want to jump right into it. So, hypothesis test. What we're testing for is if there's a difference in the average number of overtime hours worked by nurses at the 3 hospitals. So we're saying at least 1 mu I differs from the others. Or no, sorry. That's my alternative hypothesis. Sorry about that. 1 mu 1 equals mu 2 equals mu 3. The average wait time, or the average number of hours worked by the nurses at these 3 hospitals was the same, right? We'll say that mu 1, this is the average number of hours worked in Regina. Mu 2, analogous, it's the same thing, right? It's in Saskatoon. Mu 3 is the same stuff in PA. And then 2, if the assumption is that all 3 of these are equal, the way that all 3 of these would not be equal, like if this were not to be true, then we say that for our alternative hypothesis is that at least 1 is not equal to the others. And I kind of overlooked this because this is always, anytime you do an analysis of variance, ANOVA test, this is always going to be your hypothesis test, at least in this class. 3. In question 3, we have, what we have to do is we have to figure out that rejection region. So So this is my F distribution. Now the F distribution is always a one-tailed test. It's always one-tailed, and it always looks like this. Okay, and we're saying that, you know, this is our 0.05, and this is F. F out. We'll put an alpha near there, just to be consistent. And what we really have to do is this is our this is my between degrees of freedom, and this is my within degrees of freedom. So again, if I go over here, the df between is 2, and the df within is 21. So I'm looking at 3.4668. So F alpha, the critical value, 3.4688. It's equal to 3.4668. Well, and then we have to figure out the test statistic, but we already did that. So test stat F equals, flip to this page, 1.962. So 5, we reject, or no, sorry, we fail to reject the null hypothesis. And then 6, there is insufficient evidence to suggest the wait time or let's say the average wait time is different between these 3 cities. Or you could say between Regina, Saskatoon, and PA. You know, it's just the words. The important thing is to say there's insufficient evidence to suggest that the variable you're interested in has the right property. So that's it for now. Take care.